Right, the recorder has started and I'm going to start the lecture. All right, so are there any questions about expressions in C and C++ based on what you have read so far? Yes, go ahead.
Are we supposed to do all the lessons within that topic?
Yes, you are supposed to participate in all of the activities. Now, some do not have a due date just yet because I think, I just want to make those, in the form of a quiz so that you can kind of do it more interactively. But if I find participation rate to be too low, then I will also assign grades to those and have a due date for those as well. So right now, they do not have a due date. Let me show you what I mean by that. Okay, so I will go ahead and go to operators and types, which is the first reading material of this section. You can see at this point, there are only 12 attempts out of a class of about 40 people. And this is the assigned reading from last Wednesday. So that is a relatively low participation rate. And if this continues, I'm going to have to put a closing date on these activities and also make it count for the final grade. Because this is really necessary. You guys got to get onto these quote-unquote quizzes because that's your text. You don't have a textbook because this is your textbook. All right? Are there any questions about that part? Did that answer your question? Okay. So at this point, there's no due date for these, and they do not count for your actual grade. But I might change that because of the lack of participation. And ultimately, reading this material is not going to benefit me in any way. I just wrote the material. Okay, it is going to help you, when you participate and get through with this type of activity. So what I'll do instead is I'm going to give you a preview of what is actually in these quizzes for those people who have not even tried. The 12 attempts, is out of 40 people, so about 20-30 people have not even got into this quiz yet. Okay, and that's kind of important to get into it. So this is the kind of stuff that you will find in it. It is your reading material. An operator in C, C++, in a symbol, and so on and so forth. And each slide ends with a question. To answer the question of each slide, you only need to read that particular page. That's the structure of these so-called quizzes. Okay, so it's by default open book because the answer to the question is on the very same page. So the design of this is really just to get you guys to participate and have a little question to see if you understand the material on the same page or not. Okay, you have an infinite number of retries. Okay, if you get a wrong answer and you later on find from your grade book that you got a wrong answer, try again. Okay, so there's no penalty whatsoever for just okay, I glanced through the paragraphs. I think the answer is this. Well, if it turns out to be wrong, well, read more carefully and try again. So are there any questions about this type of activity? No questions? Okay. All right. If there are no questions about this type of activity, what I will do in class is to demonstrate things that would be difficult to demonstrate without being recorded in video. Okay, so that's the main objective of the face-to-face time, is to deal with all the stuff that is difficult to convey without an interactive demonstration. All right. So what I'll do is I am going to write some programs, and we'll try to figure out what the code is going to do. We'll start with some simple ones, and then later on we'll move on to some slightly more difficult ones. All right. Yes, go ahead.
Real quick about the for some reason, Avast keeps saying that the uninstall file is a virus. Do you know what reason that might be?
Which software is complaining here?
Avast antivirus. Like every time my computer boots up, I have to cancel it from parts of the
Huh. Do you know exactly which file is complaining about?
Yeah, the uninstall file.
The uninstall file?
Yeah. It's like Linux/qnp-uninstall.exe.
There's no uninstall file. There should be no uninstall file.
I'll have to double check it.
So You might be on. Okay, your antivirus program actually may be onto something, but it's not something from my distribution. I can show you what it should look like. So if I go to downloads, go to, oh, I don't have it here. But there should be no uninstall file because everything is already pre-installed. And it's just installed by unzipping files. I don't have it here. Let me see if I can find it somewhere. Yep, there we go. Okay, so I'm going to my Linux folder, which is what you should be seeing. I don't see any uninstall file here. Is it under a subfolder? Okay. You see one? Okay, so if you QEMU64. Okay, so there's a QEMU uninstall.exe file, and that's the one that it complains about that it has a virus. Okay, I don't think I have the antivirus scanner here. It's called CLAM. Nope, I don't have it here. Okay, so let's find a website. What is a good website to do a on-the-fly web-based scanning? Yep. Virus. Total?
Yeah.
Is it a .com?
I believe so.
All right. I don't think it's a virus. I don't think it contains virus, but we'll check. So choose file. So I just want to settle this, before we continue any further. Okay, QEMU uninstall. Okay, thank you. Okay. This file was last detection ratio is 2/57. What does that mean? Yeah.
It detects through a variety of different antivirus programs. API analysis will tell you which ones it found a detection on.
Okay.
See, that's just a false positive.
Yeah.
Okay.
It says Avast shouldn't even be picking it up.
Say again?
On there it says it should pass with Avast.
Oh yeah. Yeah, right here. Yeah, that's a check mark here.
So could be.
So it should be I think it's a false positive.
Yeah, I sent them the form saying that I thought it was. I just wanted to check.
Okay. Well, that's good. It's good to let me know so that we can actually check it to be sure. All right. All right. So with this out of the way, we're gonna start to write some software. Okay. So not software. We'll start with some simple programs. And let's go ahead and start with some programs related to expressions. What? I thought there was a question. Okay. All right, so what I'll do is I'm going to remove my folder. Does anyone remember how to remove a folder? RM, go ahead.
Yeah, I was gonna say, well, are you removing everything inside of it?
Yep, everything.
RM-R for recursor?
Mm-hmm. And then force to it's F, but let's just do that, and that will do it. Okay. So it's really easy to make a mistake and delete stuff that you do not intend to delete. Okay, I'll show you a variation of doing something like that that is definitely devastating. What does a single dot mean in not just Linux, but in almost every single command line interface? What does the period means? The current working directory. Okay, so when you do something like this, you are telling RM to remove everything in the current working directory, which is everything. Okay, so it's very easy to make a mistake and end up with all the files gone. Okay, so just be careful when you do something like that. So I'm going to remake the folder called test, change to the folder called test. You don't have to do this, I'm just doing this so that I can contain all the examples within this folder. And we'll go ahead and start with the first program. The first program is going to have int main open curly brace, close curly brace. This is a template for all the programs that we'll be writing in this semester. Okay, the main function is the entry point of the entire program. Now, I don't know, what was taught in your CISP 300 or 301. In C and C++, everything, all the code must be inside a function. So in order to start the execution of one entire program, you have to start execution in the main function. The main function is the entry point of the entire program. Are there any questions about main being a little bit special? Okay, that's all. That's good. Okay. The int part, I'm not too concerned about that part just yet because we haven't talked about return values. Okay, so we'll deal with the return type of a function when we get to that point. All we want to do at this point is to do some expressions. Okay. This is a valid program. It doesn't do anything useful, but it is a valid program because 3 plus 4 is an expression. Okay. Now you can turn any expression into a statement using which symbol do you think, which punctuation turns an expression into a statement here? Semicolon? The semicolon symbol, exactly. The semicolon punctuation turns any expression into a statement. 3 plus 4 by itself is an expression. It has a value of what? 7. And what am I doing with that value of 7? Absolutely nothing. So even though this is syntactically correct, it doesn't do anything useful. Okay, we'll try something else. Okay, x equals 5. That is also an expression. Now remember, last time we talked about the equal symbol. A single equal symbol is not for comparison. It is an assignment operation, but it's not an assignment statement by itself. It is an assignment expression. Okay, because the equal symbol assignment is an operator. So we can do all kinds of fun stuff. What do you think will happen when I compile this program? Now let me just go back to my own notes here so that you can see, which part we are talking about. All right, scroll some more. All right, variables and the assignment operator. Okay, so if you have done that part already, then all the stuff that I'll be talking about should be somewhat familiar. Okay, all right. So what is one thing that you learned in the variables and the assignment operator quiz? Let's click it and find out. And I'll just continue my last preview. Okay. Here we go. So what this is saying is, how many people are not familiar with the concept of a variable? Okay, that's good. That's the kind of answer that I'm looking for, because the concept of a variable should be discussed pretty much first thing in CISP 300 or 301. Okay, so basically a variable has a name, it has a type, and it has a value. Okay, and the value can change over time, and that's why these constructs are called variables, because they can vary. So to declare a variable, we use the syntax like this. Okay, int x semicolon is a declaration of variable x. It's basically telling the compiler and say, hey, we might need to use a variable from here on, and I want to call the variable x. It is going to store integer values. So it's an int type variable. Okay. The rest of this slide is really just explaining what each line is doing. It even talks about the open and close curly braces. One to open the body of the function, one to close the body of the function. And the question is, what is a variable declaration, which is something that is already discussed on this page. So that's something that you have to do, is to participate in these quizzes. So as you read through the slides, it will double check and make sure that you are understanding that page correctly. Now, I'm not going to answer the question here. Instead, I'll just kind of move on to the second one. The assignment operator. Okay, so what I may not have said is, but what if you forgot to declare a variable before making use of it? Okay, let's check it out. Now, one thing that's nice about programming is most of the time you can actually test the response of a compiler by artificially introducing an error. It's like, okay, I know this is wrong, but I want to see what the compiler is going to complain when I do something like this. Okay, so we'll do it GCC, and in this case, I'm just going to be using -C without all the other options because the program is not going to compile anyway. And it gives me an error of x is undeclared, first used in this function. All right. So that means I need to have a declaration of x. Yep, go ahead.
I know, for at least for Nano, when you try and compile something with syntax errors and print out an array list with roughly what it is, does Vim have a similar function, or do you have to go to a different?
That I do not know. I just go back to line 3 because it does tell you that it is on line 3. So I just go back to line 3 and see how to fix the program. Okay. But in this case, I cannot fix the program just by going back to line 3 because what am I missing in this program? Let me show the program again, and you guys can help me fix this problem. What am I missing?
Data type for
Okay, I'm missing the
Type area.
declaration of x. I start to make use of a variable that has not been declared. Okay. Now I know if some of you came from a background of using some scripting programming language, such as PHP, and in many scripting languages, declaration is not required or not even possible. Okay, so you can start using a variable in the middle of nowhere, and it will just magically appear. In C and C++, that's not the case. If you want to use a variable, you have to declare it first. Okay, are there any questions about this part? No questions? Okay. Let's go ahead and compile this program. This time, I will compile it. I can use G++, but it doesn't really matter that much because at this point, I'm not using anything that is specific to C++ or C. This is pretty much the intersection of the two programming languages. I'll do a warn all. Do you think this time the compiler will warn me about something based on what we learned last time? It will warn me because I am declaring a variable x. That's good. That's not a problem. I assign a value into variable x. That by itself is not a problem. But what did I do with x after that? Nothing, right? So when I turn on warn all, okay, it will tell me that I put a value into variable x, but I'm not using it for anything. Okay. That's okay, just so that we know what kind of problem, what kind of messages may come back from the compiler. -G, what is the purpose of -G? This is a quick little question from last class, from the previous class. What does -G specifies to the compiler? Sounds like you guys need to watch that video from from Monday again. -G means I want to turn on debugging options so that later on I can use GDB to debug the program. Okay, so -G is something useful because I intend to go through GDB to debug this program. All right, what about -C? To compile, very good. And then we can supply the name of the source file. Okay, in this case, it's just a .c. I could have made this a CPP extension. It would not have made any difference in this case. All right, so we compiled the program, and as expected, as I said a little bit earlier, the compiler did warn me about variable x is set, which means it's initialized, but it is not used. I never refer to the value of x after that. Okay. That's fine. The program, still compiled. Do a ls. I show the content of this folder. In addition to the source file proc1.c, now I have a second file proc1.o, which is the object code of the same program. Can I run this code? Can I do a /proc1.o? Would that work? Well, let's try it. It says permission denied because it has no execution permission. But even if I am to turn on the execution permission, it still would not run because I'm missing which step? Linking. Okay, I compiled. but I also need to do the linking first before I can, before I have the executable. So G++ -O specify the output file name of the linking process, and then we specify the object file, and the linker is now done, and I can now run the program. Well, I just forgot. This program does not have anything to print out. It doesn't do any input-output. So how do I know this program is actually working, that X is getting a value of 5? I think I showed that tool just briefly the other day. It's called GDB. Now, GDB was not installed, if you remember from last time. Did I go through this last time or not?
I think so.
Okay, yeah, that might be my other class. Okay, so I have to install it. You guys don't have to do this because the virtual machine comes with GDB installed already. I just forgot to do it to the live environment that I'm using here. So I will have to install that. Aptitude install GDB. All right, I'm gonna close the door because it's a little bit noisy outside. All right. So what I just did with the previous command, which is aptitude install GDB, this particular command up here, that is one single command to go out to the internet, to download a package file, get it installed. So it's pretty handy, okay? Most distributions can do this, whether it's Red Hat or Debian, they can do this. You guys okay? Do you have any questions? Go ahead. No? No questions? Okay. All right. So now we can use GDB. Now GDB is the debugger, okay? This is what we'll use to debug programs in this class. GDB prog1. Prog1 is the name of the executable. So when you use GDB, you do not use the source file name. You use the name of the executable. So you can now press the Enter key, and it prompts me, it gives me a lot of information like this. Okay, it's a little bit overwhelming for people who are just getting started, but at some point, you get used to it. The first command I want to use is called list. Okay. Now, if you don't remember how to use a list command, you can always say help list, and it will give you a short description of how to use list. The most common use is really just L all by itself, and it will just show you the current function that we are in. In this case, is main. Okay. But why do we want to use a debugger? Well, so that we can do something like this. B4. Okay. B4 means I am setting up a breakpoint on line 4. A breakpoint is a place in the program where execution will stop, okay? But it's not stopped permanently, it is just paused, okay? It's just suspended. That gives me a chance to examine the values of my variables. Now, when we get to branches, loops, and stuff like that, a breakpoint can also help me confirm, did I even get to this branch? Did I even get to this line to execute? So it's very, very useful as a tool. Just by itself, a breakpoint is useful already. So B4 is setting up a breakpoint on line 4. Once again, if you want to know all the options of setting up a breakpoint, you can say help breakpoint, B-R-E-A-K-B-I-T, and, whoops, I guess that's not the case, help B. Okay, there we go. So it basically says set breakpoint as specified line or function. It comes with a lot of different options. You can do a lot of fun stuff with a breakpoint. We'll just be setting up breakpoints on individual lines. Okay, so none of this other stuff we have to do in this class. So now that we have set up the breakpoint, we can now run the program. Okay, to start running a program is just R and then press the Enter key. Okay, that will start the execution of the program from the beginning of the program. Now you have to be careful when you use R, because if you're already executing a program and it has just suspended because of a breakpoint, if you do R again, it will start execution from the very beginning again, which may or may not be what you want to do. Okay, so when I do a R, it now stops on line 4, which is the statement where I wanted to stop. So the big question with a breakpoint is, when it stops, has the processor executed this particular statement or not? What do you think? I set a breakpoint on line 4. Now it has stopped on line 4. The question is, has this particular statement executed at this point or not? Yep. Has not. Yep. That is the correct answer. This statement has not executed yet. So what I can do is I can use the print command and say, tell me what is the value of x prior to x equals 5. Okay. So I press the enter key. It says it's 0. Okay. It's just it can be any value, because a uninitialized local variable can have any value. 0 being one of the many values. Okay, now I want to execute this statement. To execute a single statement and then stop again, you use a single step. Or you can just use the lowercase letter s for step. So what this will do is it will execute line 4 and then it will stop immediately again. It does not continue execution at full speed. It just executes one statement and it stops. So single step, press the enter key. Sure enough, it stops on line 5 because line 5 is right after line 4. Are there any questions at this point? No questions? Okay. Now I can say print x again, and sure enough, x now has a value of 5. Now, some of you may be asking, or may have observed, and say, what is the $1 and the $2? What are those things? The $1 and $2, those are values that are being tracked by the debugger. In other words, later on, if you want to refer to the result of a previous print, you can do that by its number. Okay, let me show you by what I mean by that. If you say print $1, it will print back to 0 because it is the result of the first print statement. So this is a nice and nifty way for you, so that you don't have to keep track of the values. You can just go back and say, oh, I want the result of that previous operation, and you can grab it. Yep.
If you're gonna just run it without the breakpoint or anything, would anything pop up?
Absolutely nothing will happen. Okay. Okay. So here, that's a very good question. So I want to finish up the execution of this program. If you just want the program to run at full speed, unless there's a breakpoint, you use lowercase c for continue. So use C, press the enter key, and the program will execute. This is how it will exit when it's normal. So it will say inferior 1, which is actually referring to the first thread of the program. We're only going to write single thread programs in this class, so it will always say inferior 1. Process 3197 is identifying the process that has just exited, that has completed. 3197 is going to change. You're not going to see the same value here. This is called a process ID. A process is a program in execution. Okay? Okay, so let's kind of slow down here, and I'll just explain what is a program and what is a process. Okay? I just said something. A process is a program in execution. So let me ask you another question. How many processes can correspond to the same program? Any number. Can be 0. Okay? If a program is just a file sitting in the file system, there can be 0 process corresponding to it. Or I can run the same program over and over again, not over and over again, but start it up multiple times. Then I can have multiple processes corresponding to the same program. If you want an analogy, here's an analogy. A program is nothing more than an operation manual. Okay? It's a binder. Okay? It just contains the instructions of how to do something. By itself, it doesn't do a single thing. What a process is kind of like a worker following the instruction of an operation manual. So given the same operation manual, multiple people can be reading it at the same time and doing things in parallel. So that's the analogy. Okay, a worker following the instruction of a manual is a process, but a program is nothing more than the operation manual itself. Okay. All right. Exit it normally. Okay. Doesn't sound very suspicious. You will only get this message when you return 0 in main. If you return 1 in main, it will say exited with a code of 1. Okay? So anything that is 0 is considered quote unquote normal. Anything other than 0 is quote unquote not normal. And this message will change. It will reflect the actual value being returned by main. All right. And are there any questions about this, all this stuff here? I can give you a quick summary of the commands that we have just used. So this will help those of you who want to kind of get a quote-unquote study guide to use GDB. I will not ask questions. By the way, I will not ask questions in quizzes and also in the exams of how to use GDB. GDB is a tool, okay? I've introduced the tool. I will tell you how to use it. But whether you use it or not to write your programs is entirely up to you. Okay? Would you use it? Well, it depends on what kind of program we are writing. Okay? So I'll just do it. Let me finish this part first. Okay? L is list. B is to set breakpoint. C to continue execution, full speed. S for single step, one statement at a time. What else do we go through here? R to run the program. I think that's about all the commands that we have talked about. Oh, print. Okay, you can print value expression. Okay, so this is a quick summary of the commands that we have used. What I have just done is being recorded as well. Okay, so if you need to refer back to it, you can watch the video again. Here's another little tip. Some people find it useful when they are taking notes. Okay, now since you know that I'm recording everything, you may not feel the need to write down everything that I do on the projector. But what might help you is to keep an index. Okay, so you can say, okay, about 32 minutes into the class, Tech is done with demonstrating how to use GDB. How would that help you? Well, if you ever need to go back and revisit, how to use some of these commands, you know the time frame within the video of where to look. Okay, so you don't have to scan through the entire thing looking for that one little bit of information. So keeping track of an index of how I teach the class, which part is recording what, can be helpful when you're reviewing the material through the video. Okay. Are there any questions at this point? Yep, go ahead.
You had said if you're returning anything other than 0, the statement will change at the end.
Yep.
Are you just referring to where you have return 0 up there?
Yes, that is correct. Because that is actually used as the exit code of a program. Every single program in Linux is going to exit with a code. If the program doesn't detect any problem, it's just a normal exit, it should return a 0. Now, in this class, we'll never really use the value of the exit value, but it is used by scripts a lot, okay, so that they can tell whether a particular program completed without any problems or not. All right. So this is a quick introduction to GDB. Don't worry if you don't quite get everything today, because I'll be using GDB every single time. Okay, this is the most useful tool for this class when you need to debug a program. All right, so we'll go ahead and take a look at a second program. Okay, so the second program is going to have the same template here. Okay, and this time I'll introduce one single variable x. But this time I'm going to do something a little bit interesting, okay? So we'll give x a particular value, let's say 5. And then we'll do some expressions, okay? X gets x plus 1. All right. If you take a look at line 5, a mathematician would look at line 5 and say that it makes no sense whatsoever. Why do you think that is the case? Because to a mathematician, what is the meaning of the equal symbol? You're checking, right? You're checking whether the two sides have the same values or not. Can x ever be the same as x plus 1, regardless of the value of x itself? Can never be the same, right? So a mathematician would look at line 5 and go like, it doesn't make any sense. Well, fortunately, you guys are not, well, in this class, you're not a mathematician. I know some of you are math majors, but today, in this class, you are learning how to program. You're learning how to code. What does it mean in the programming context? This should be in your cisp300 or 301. Yep, go ahead.
So, the assignment operates right to left. It just grab what the value of x plus 1 and assign it to.
Absolutely. Okay, so you just exactly as you said. So the order of evaluation is we first evaluate the right-hand side. So when I evaluate the right-hand side, x still has a value of 5, right? 5 plus 1 is 6. So the right-hand side of the assignment operator is 6. What do we do with the value of 6? This is an assignment operator. Well, we update the left-hand side with that value. So as a result, after line 5 executes, x will end up with a value of 6. Okay? This is something that you should have learned in cisp300 or 301. I'm just refreshing your memory here. Okay? Yep, go
How do
ahead.
you put the numbers on the set?
Say again?
How do you put the numbers on the set?
Set NU, colon set NU in VI. Yep.
If your thing just like freezes, it's still running, it just won't type anything.
Uh-oh. Your virtual machine?
Yeah, it's got the blinking cursor, it just won't type.
It's probably waiting for you to type something. Try Control C.
Try that.
Does it get out? No? How about Control Z? No? Okay, I'll have to take a look later. Okay, so let me finish the lecture portion first. Okay, so this is fairly easy. Okay, so now we'll start to get into the comma expression. Okay, remember last time I talked about several operators that are kind of unusual. Okay, we all know about addition, subtraction, multiplication, and stuff like that. Parentheses, yeah, we know that stuff. But what about commas? Okay, let me see if you can remember what we talked about last time. So if I do a x equals to, well, this would be a good one. 1, 2, 3, 4, 5, x plus 1. Okay, what do you think after line 6? What do you think will be the value of x? But exactly what it is. What is the actual value? It will be 7. Okay, it will be 7. What about all of these things here? 1, 2, 3, 4, 5. They're all kind of useless. Okay, because in a comma separated expression, only the value of the last expression becomes the expression of the entire thing. Okay, that's what we talked about last time. Okay, how many people still kind of remember that part? Okay, very good, very good. All right. All right, so just the way it is right now, okay, I predicted that after line 4, x has a value of 5. We verified that already. That's not a mystery. After line 5, it has a value of 6. Now I'm claiming that after line 6, it should have a value of 7 because in a comma separated expression, only the value of the very last one becomes the value of the entire expression. Okay? But do you trust me?
Yeah, sure.
Just because I'm standing here, you're trusting me? No, you should not, okay? Because, well, with certain types of classes, it's hard to verify stuff. But with a computer science class, with a programming class, what can you do when you say, well, I cannot trust tech 100%? How do you verify it? You can use GDB to check it. Okay, so I'm going to do this just one more time. just so that we are familiarized, we get familiarized with the commands. Okay, can I do something like this right away? Would that work? Nope, it does not work. Well, it actually does not work because GDB complained and say proc2, no such file or directory, because I have not compiled, I have not linked, so I have to do both of those steps first. Okay, fine. So we'll do a g++-1 all dash c, dash g dash c. These two can swap, it doesn't really matter. proc2.c, c, yep, that's fine. Right operand of comma separate operator has no effect. That's okay. Okay, we kind of know that already. And then we'll do the link part, g++-o proc2 proc2.o. Now we can run the program. /proc2. Would that be helpful to me? When I run this program, does it give me any type of input or output by itself? Nope. So when I run this program all by itself, it will just do this. Absolutely nothing happens. It doesn't crash either, but it doesn't do anything useful. So to check the concepts that we have just talked about, we can use GDB. So we say GDB proc2, list the program, put a breakpoint on line 4, and start running the program. Okay. Now we are on line 4. We can print x to see what is the value of x prior to line 4. It's going to be 0, like last time. Yep, go ahead.
I was wondering, a little farther up when you were running GDB and had the carry pointing to the various values that the phone operator. Why was it, yeah, like right there. So I understand like why it was pointing to like 3, 4, and 5, but then why was it pointing to the 1 and plus operators while saying that it was the error with something else? Because previously it pointed to x when x wasn't declared.
You are absolutely correct. I think it has got the cursor position wrong.
Okay.
I think it got the cursor position wrong, but that's just my thinking. Oh, you know what? It might have to do with the priority of the comma versus the plus. Okay. You can see the, okay, 5, that is interesting. You're absolutely right. So we'll use GDB to find out whether I interpreted this expression wrong or not. So single step line 4, x now has a value of 5. Single step line 5, x should have a value of 6. Single step line 6. Now I think x should have a value of 7, but there is a chance that I am off. Okay, because what I'm counting on is the plus operator has a higher priority than the comma operator. Okay, what is the priority of an operator? What does it do? Okay, go ahead. The order is going to be evaluated. So when you have a mixture of operators, then you have, and without the use of parentheses, how do you know which operator to evaluate first? So I will cheat a little bit and go to a page that talks about operator priority. Operator priority C++. And I'll just go ahead and look it up. Okay, so plus addition is here. The precedence level is at 3, okay? So it's a fairly low priority. And then you have to look up comma. Where is the comma? It's all the way down here. So what is that telling you?
Add operator first.
It will perform the add operator first. Wait. No. That's... Yes, you're correct. Because the plus operator has a priority 6, and the other one is all the way down. So it should perform the the plus operation before the comma operator. Yep.
What's the difference between, it says on priority 3, it says unary plus minus. What's the difference between plus minus on minus?
Unary means it's just one operand, it's only one side. So minus 3 all by itself is using minus in a unary sense. 5 minus 3 is a binary operator because it has two operands, two things to operate on.
Does that have more to do with like assignment?
It has more to do with the placement. Okay. Let me give you an idea. Okay, so if you have, if you have this expression here, this minus operator is the unary version. Okay, so it takes precedence over the multiplication. On the other hand, if you have 1 minus 3 times 3, in this case, this is the binary version of the minus operator, which has a lower priority compared to the multiplication. So in the first case, it will first compute 3 times 3 and then negate, excuse me, I take it back. It will first compute negative 3 and then multiply it by 3. It still ends up as negative 9, but that's the order of operation. So with this one, it is the same as this. With this one, it is the same as this.
Okay.
Okay, so is that making any sense? Okay. But based on this, the comma operator actually has the least priority, so it is the lowest. So that means we'll perform the comma the last. So when I print x, I should expect a value of should be 7. And it's not. It is actually 1. Okay, so I am actually wrong in this case. See, it's a good thing to check, good thing to verify. All right, so let's take a look at the comma operator because I'm fairly sure that the way I understand it is correct. But in a comma's expression E1 and E2, the expression E1 is evaluated, its return value is discarded, and its side effects are completed before the evaluation of expression 2. Okay.
So does that mean it discarded the x plus 1?
This might have to do with the compiler trying to optimize things, so it took away things that do not have any side effects.
Well, because the first number that you put was 1, and then it said it gets rid of any operator after a comma. So
Because those have no side effects. Yep, that's probably what it is, because it took away all of the other expressions. So, okay, this one takes a little bit more explaining, why the behavior of the program does not match what I think it should be doing. It's the compiler being smart. Okay, so think about it. The compiler is looking at the expression. Let me just get back into the source code because it's just easier to read it in the editor. So I'm going to get out of the debugger, go back into prog2.c, and just focus on this particular line 6. Okay, this 4 should not be here. There we go. All right. So what the compiler is saying is the only real use of a comma operator is when you have a whole bunch of things that have what we call side effects. In other words, they do something by themselves. Okay. So in this case, does 2 do anything other than specifying the value of 2, which is going to be discarded? No. What about 3? Doesn't do a single thing. What about 4? No. 5 doesn't do a single thing. Even x plus 1 does not do anything, because x plus 1 will evaluate the value of x, add 1 to it to end up with another value. What do we do with that value? Also, nothing. Okay. So the compiler is looking at this, looking at 2, 3, 4, 5, and x plus 1 and say, none of those actually do anything that's useful, and is quote-unquote optimizing them out. And that's why the actual code produced is only preserving the first one, and as a result, this entire expression, the compiler, without letting me know, is optimizing it to be just x equals 1. Now this is a good time to introduce the // symbol. It is the comment symbol. Okay. In other words, everything from // all the way to the end of line is considered comments. Yep.
Why are job plans from left to right if the order priority is right to left?
That is also a good question. I do not know. That's just the compiler doing its optimization, but you are right, it should be optimizing the other way around and keep the last expression. Yep.
So what would be a useful operator to go after a comma, if there is any?
Well, let's take a look. I will go ahead and write another program to illustrate that point. Okay, that's a very good question. PROG3. Okay, there we go. So let's say we have two variables here. Okay, so int x, y. So now I'm declaring x and y both as integer variables. And what we'll do is we'll do a whole bunch of stuff here. So we can say x equals 1, y equals x equals, I'm not really 100% sure whether this will work or not, but we'll give it a try. And let me see if increment is discussed anywhere in this. I think it should be in here, but I'm just double checking. Yep, so in unary operator, that's the plus plus operator. I think I'm not going to use that one. I'll just do it like this. Okay. All right. So this is an expression that is comma separated, but also at the same time, each sub-expression does something. Okay, yep. Oh, okay. So when you look at this line, let me show the line number. When you look at line 5, it is just, 3 expressions. The first expression is x equals 1, which definitely has a side effect. Okay, it changes the value of x. The second one is y equals x, which also has a side effect because it also changes the value of y. The last one is x equals x plus 2, which also changes the value of x, and x should end up with a value of 3. Okay, so we'll go ahead and introduce one more variable z here, and then we'll say z equals this stuff plus 2. Okay. All right. So what do you think should be the value of z? Should be 5, right? Okay. All right. So I predict that x should end up with a value of 3 after this is all done. Y should end up with a value of 1, and z should end up with a value of 5. Are there any questions about this? Okay, when you look at something like this, you have to look at it from the perspective of the compiler. The compiler, even though it's a very complicated piece of software, it does follow a set of rules. Okay, so the set of rules has to do with comma separated expression. They're always evaluated from left to right. Yes, go ahead. Okay, so if a comma separated expression is always evaluated from left to right, this will be the order that they're going to be evaluated. But in a comma separated expression, the value of the last expression, which is what I'm highlighting here, is the value of the entire expression. So the final value of x ends up to be the value of this entire expression. That should be 3. 3 plus 2 is 5, and that's the last operation, is to change z to have a value of 5. Okay. So we'll go ahead and check whether that is the way it works or not with the compiler. So do g++ dash warn all. It's going to warn a lot of stuff, okay, because all the variables are set. Well, I take it back. 2, it will complain about 2 of them, but not x, okay, because x is actually used already. So that's g prog3.c. How many people think it will complain about x, y, and z? How many people think it will only complain about y and z being set but not used? Okay.
I think it'll only complain about y and z.
Okay, because x is actually referred to, during the expression. Yep, so it's just complaining about y and z because I used x when I changed x. When I say x equals x plus 2, that's making use of the value of x. All right, so let's go ahead and link the program. And then we can just go ahead and debug the program. List, put a breakpoint on line 5, and just run the program. All right. Now we already kind of know the value of x is 0 from the previous times. Okay, what do you think would be the value of y and z?
It should be 0.
Well, they're uninitialized at this point. So all uninitialized local variables can have any value. There's no guarantee that they should be 0. So y ends up to be some kind of strange value, and z is some kind of strange value too. This is something that you should always remember. Okay, local variables, it applies to global variables as well, but just basically any variable has an unknown value initially. So you have to remember to initialize your variables before making use of those variables. In some programming languages like Perl, okay, or PHP, a variable can start to exist out of nowhere, okay, and it already comes with a default value of 0. That is not the case in C++. Okay, all right. So we put a breakpoint on line 5. We already put a breakpoint on line 5. We single step, and then we print x again as a value of 3. That's good. Y has a value of 1. That's good. And z should have a value of 5. And that is the case as well. So when the sub-expressions separated by commas do have a side effect, they don't get optimized out, and the program does work the way it's supposed to. Are there any questions yet at this point? Yep.
So it's only if they're not used, we're going to throw it out.
Correct. If it has no side effect, it will throw it out. At least this compiler will throw it out.
So this one did throw out because we were adding them.
That is correct.
The side.
Yep. So when you look at the source code, when you look at each one, they do something, right? So other than just specifying the value of 1, this expression does something else. Okay, it changes the value of x. This one changes the value of y, and this one changes the value of x again. Yep. All right. Any other questions? How far along are you guys reading the material? In other words, if I go back to this part here, the grayed out parts, don't worry, you won't be able to see it, okay? So just out of the not grayed out portion, where are you guys at? All the way down? General compound assignment operators? That's pretty good. How many people have gone through at least logical versus bitwise operators? Okay, very good. Are there any questions? Yep.
The example that you were showing, do we have to do that sort of debugging ourselves?
Do you have to do what?
That was the debugging you were showing.
Yes.
Do we have to do that by ourselves?
It is not required, okay? But every single time you learn a concept, it is helpful to write a small program just to test your understanding of the concept. Okay, it's not required. Okay, it is something that I think you should do. Occasionally, especially the tricky one. The really easy one, sure. I mean, just you read it, you think you understand it, just move along. But with the more complicated ones, it is really helpful to write a short program just to test whether your understanding is correct or not. Okay, let me just ask you guys one thing. How many people have read this particular slide, particularly the ternary operator? Okay. Are there any questions about the ternary operator? No questions. All right. So what I'll do is what about the unary operators? Is that okay? Okay. Well, let's deal with the ternary operator. This is one of the really interesting part of C syntax, because you can do a conditional statement as an expression. That's what a ternary operator is. So we'll go ahead and write the fourth program, okay? And make use of maybe 3 variables here. And then what we'll do is we'll have x equals 1, y equals 2, and here's z. I want z to be the maximum of x and y, okay? regardless of how I initialized x and y to begin with. So what kind of expression will do this?
So the maximum of x and y?
Yes.
Like whichever one's larger.
Whichever one is larger, correct. But how can I do it with a single expression without using conditional statements? So I'm not using if-then statements. I'm just using a single expression to do what most other programming languages will require a conditional statement.
You use a greater than symbol, but I don't know how you place the x and y.
Aha! That's why I mentioned the ternary operator. Okay? So for those of you who have not read the ternary operator, after this, you still have to read it. Okay? I'm just giving you a preview of what you can do. So how you do it is you compare x and y first. That's the first component. This will return a 0 or a non-zero value. A 0 value means x is greater than y is false. If x is greater than y is giving you a non-zero value, it means it is true. X is actually greater than y. This is one thing you also have to remember. There's no such thing as a Boolean type in C++ programming, or in most cases, we don't consider it as a type. 0 means false, non-zero means true. That's the bottom line. So a ternary operator has the first operator, or the first symbol is a question mark. It separates the condition from the other two expressions. The next expression is what we call the then expression. This is evaluated and it becomes the value of the overall expression if x is greater than y. So if x is greater than y, the maximum is x. And then we use a colon to separate the then value from the else value. The else value in this case is y. This single expression here will actually find out which one out of x and y is larger, and z becomes the value of the larger one. Okay? Are there any questions about this? Let me just explain that one more time. Okay? A ternary operator has three parts. The first part is a condition. It's either 0 or non-zero. If this expression is non-zero, it will take the second expression as the value of the overall expression. If the first expression is in fact 0 or false, then it will take the third value as the value of the entire thing. Okay? Are there any questions?
Can you repeat that one, Sam? Could you repeat that one?
Okay, you're lucky because most of the time I would have forgotten what I said like 20 seconds ago. Okay, go ahead.
So if the value is non-zero, the value will be x, and if the value is 0, we get y.
The value of this expression, that is. Okay? Okay, so what it will do is it will first evaluate this expression. The first one is always going to be evaluated because it is the condition. X is greater than y is a condition. It will always return a value that is either 0 or non-zero. If it returns a value that is non-zero, it means x is in fact greater than y. If it returns a value of 0, it means x is greater than y is false. Is that okay so far? Okay, so this one is always going to be evaluated. But based on the result of this expression, it will evaluate this one if and only if x is greater than y is true. And that becomes the value of the overall ternary operator. On the other hand, if x is greater than y is false, then it will evaluate the third expression and use the value of the third expression as the value of the overall ternary operator. Okay? Yep.
So is that, are there any other ways to do a true-false expression?
Yeah, you can use a conditional statement.
Okay.
Yeah, but this is basically this is rolling a conditional statement into an expression. So that's why in C and C++, expressions are much more powerful compared to other languages. Because guess what? These two expressions, if the condition or if the situation calls for it, these two can be a long, comma, separated expression with assignments inside. Okay?
Would you be able to do it the other way also, though?
How so?
Like with a condition statement, wouldn't you be able to do that?
You can do it with a conditional statement. But what I'm trying to make a point saying that in C and C++, expressions are actually more powerful than expressions in, say, Visual Basic and many other languages.
Okay.
So keep.
What are like the advantages of doing it that way?
So you can write code that is really cryptic. No, I'm just kidding you. The reason why you sometimes it's helpful to do it like this, because what if you want to pass a different value to a function based on something? But the function, let's say you have a function that has 5 parameters. Only one of the parameters gets a different value depending on the condition. So the traditional way of doing it, of using a conditional statement, is going to have a replication, okay, a duplicate of the function call with only one parameter being different. And then you use a conditional statement as the outermost structure to structure this. Which is okay, but there's a lot of duplicate code because the other 4 parameters are basically the same. But using this, you can use a single function call, and whichever parameter depends on the condition, we'll use a ternary operator to decide, okay, this time should we use this value or that value. So there are certain situations that actually makes it really handy, and it makes sense to make use of the ternary operator. Okay, all right. So we'll double check on this one. Okay, we'll run this program. This may be the last one we'll trace today. So we'll say g++-1all -c-g prog4.c, and then g++-o prog4.c .o, and then gdb prog4. This is the program. I don't think we have to set a breakpoint on line 5 or 6 because those are fairly simple. So I'm going to set a breakpoint on line 7 and run the program up to line 7. At this point, if I say print x, okay, print y, that's pretty, boring. We already know the effect of those 2 statements. Single step, print z, and it has the maximum. Now, what if you want to test the program again, but this time you want to make x having a value larger than y? What are your options? In other words, we can see that it works in one way, but by no means is this actually verifying the logic of the ternary operator. I want to test again, but this time I want to make x having a value of 2 and y having a value of 1 and retest this code. What should I do? The first approach is really kind of tedious. I get out of the editor, GDB, I get out of the debugger, go back into the editor, recompile the program, change the program first, recompile, relink, and then go back into GDB and do this all over again. That really is kind of cumbersome. The second way to do it is to make use of GDB. So I will run the program again, do R, and it will warn you, okay, because I have not completed the execution of this particular process. That's okay, the rest of the program is really boring, I don't need it. So I'm going to say yes to start from the beginning again. And once again, it stops on line 7. So you will say, oh, but it's going to do the same thing all over again. Yes, unless I change the value of x and y on the fly in the debugger. And you can do that. So you can say set var, set variable x equals to 3 if you want to. Set var y equals -2. So this will test the ternary operator in the opposite direction. Okay? If you're not convinced that these are working, just say print x, print y. And you can see that I have just dynamically changed the values of the variables in the program before proceeding. Yep.
Does that change it globally, or where you put the breakpoint?
What do you mean by globally? There is only one variable x and there's only one variable y. So
I mean, like,
from here on, okay, what I can say is from here on, okay, if the program has like 20,000 more lines to execute, from here on, x has a value of 3 and y has a value of -2. Yep.
That changes the executable file.
Nope, it does not change the executable. Yep, only within GDB, within this process, I'm changing it. But it is very handy because you don't have to get all the way out, change the program, and then go back into the same point because you can just change it on the fly. Yep.
Setbar would work for, like, that command would work if there were, like, pairs or drills or anything like that. Like, it doesn't just have to be for setbar.
That is correct. But at this point, we only deal with integer variables, and that's why, they're all integers. All right, so we'll single step again, and this time 3 is the maximum of the 2, but it's coming from x. So we'll print z, and it does have a value of 3. Okay, so the takeaway, the most important part of what you should be taking away from today's lecture is one, how to deal with ternary operators. Okay, the reinforcement of the commands that you have to run to compile and link and debug programs. The debug, the commands that you use inside GDB, okay, which is, I have used basically all the same commands over and over again. But the most important part is learning the process of how to write your own small, tiny little program to verify your understanding of a concept is correct. Okay, I cannot overemphasize, the importance of that. When I was going through computer science, as an undergraduate, I could not do that. Can anyone imagine why that was not possible when I was an undergraduate student? And that was in the 80s. Okay? Why is it not possible?
Because you didn't have GDB.
Well, not only do I not have GDB, but I have to go to a particular terminal in the computer lab to use the computer, which is a mainframe computer. So having access to the computer is already a pain. Okay, I cannot just say, oh, let's try this, let's try that, while I'm studying. I cannot do that. But you guys have the luxury of doing it because guess what? You can do it on your cell phone. It's a little bit small, okay, but you can do it on your cell phone. How many people have an Android-based cell phone? And what is Android based on? Linux. Okay, and what is your virtual machine running? Linux. How many people have an iOS device? And what is iOS based on? Unix. Okay, it's BSD, but it's a flavor of Unix. And Unix and Linux are very close. They're very related. They're not exactly the same thing. So that means you are packing a full, basically a really powerful computer on a daily basis. You just have to find out, how to open up a terminal on your cell phone to do, this sort of thing. It's not easy to do it because they don't like you guys to do this sort of thing on the cell phone. But that's just, a minor point. Okay, your virtual machine can be installed on a thumb drive. And why do I want you guys to install it on a thumb drive or an external hard drive? You can bring it to any computer and do your homework assignment. Okay. So that's it for today. I think we are just about running out of time. So I'm going to stop the recorder and I'll take a look at your screen.